Hello, EMF. Thank you, calendar people. So we're going to cover two things basically today. Have I got a lot of echo there? All right, is that better? Okay. So we're going to look at calendars first, and we're going to kind of look at the different families of calendars, and I'll give you some examples, and we'll work through a little bit about the history of them. And in the second part, we'll look at some of the events, and events in those calendars, basically how you compute some of these events, because some of them are a little bit more gnarly than you might expect. So we'll begin with what we know. I'm going to look here, but actually it's over there. So if you look at the calendar on your phone, or the calendar on your wall, if you have one in your tent, it will be the 1st of June, 2024. And that's because we're using the Gregorian calendar. The Gregorian calendar is basically the civil calendar for the world. But it's also the 19th of May, if you're using the Julian calendar. And some sort of Orthodox religions still use the Julian calendar. In the Islamic calendar, it's this. In the Chinese calendar, it's this, and it is Julian day 2,460,462 and a half, and we'll cover the half in a minute. But these are examples of different types of calendar systems. So I was talking about families earlier on. This is the families, and I'll sort of go through them one by one. So every calendar counts days. That's basically the definition of a calendar. So the day counts are the simplest possible calendar you can have. They count days from some arbitrary point in the past. And these are some examples of day counts. They get a little bit more complicated towards the bottom. So day counts are probably the simplest thing you can work with. Really good for doing calendar conversion if you come into that. Solar calendars, lunar calendars, and then lunisolar are the sort of most complicated. So solar calendars, you know solar calendars, you use one every day. That's what the Gregorian calendar is. It's interested in the solar year. So if the Earth is moving around the sun, we want the calendar to be in sync with that event. So the challenge of the calendar makers, or the sort of people who have trying to make this stuff work, is to have that, you can count it in some simple, meaningful sort of way, but still have it coincide with what's going on, the events in the sky. Because essentially we're looking at sort of approximating astronomical phenomena. Lunar calendar is much rarer. There's a couple, really the Islamic calendar is the sort of the most prominent one, and we'll look at that in a little bit. And lunisolar is hard mode. You know, you're trying to do solar calendars, keep it in line with this, the sort of day and the moon and the sun, and it's very, very, very tricky. So I'm going to give you some examples of how we've come at that problem in the past. So I've got three Greek astronomers to look at. So we'll look at the classic, which is, I will first explain the astronomical phenomenon we're trying to sort. So we know a day is 24 hours. So far, so good. But a lunation, or all the phases of the moon, is almost, but not entirely unlike 29 and a half days. The problem is it's just slightly off. Same with the solar cycle as well. So you're almost 365 and a quarter. But again, it's almost. So this is the problem, is that none of these numbers go into any of these other numbers well. It's a very hard problem to solve. So what the calendar makers are trying to do is give you a system that is hopefully using integers to try and approximate what the astronomical phenomena is doing. So that's the challenge. So I'll go back to the three Greek philosophers who have come at this problem. So we'll start with Meton of Athens. This is the Metonic cycle, which is a sort of classic calendar cycle. Healy said, this is very interesting. I have seen that 19 solar years is almost approximately 235 lunar months. It's a very clever observation. It's right to within 2 hours. Well done, Meton, very good. So Callippus comes along about 100 years later and goes, there's Metonic cycles, that's interesting. If you take 4 of those and take away a day, that's quite close to 940 lunar months. So that cycle, a much larger cycle, obviously, but it's accurate within 1 day in 553 years, I think. Yeah, so very good. So he takes a bow. Hipparchus says, "Hold my wine." Right. 4 Calippic cycles minus a day is approximately 3,760 lunar months, and that is great within 20 minutes. So it's amazing what you can do with these numbers. You can get them close. But that's how it's been approached in the past. But let's look at calendars in the different families now. So I'll do solar calendars because Gregorian is the one we know, so we'll start with the one we know. Gregorian calendar comes from the Julian comes from the Roman, so we get to go here. Yeah, anyone? I'll take aqueduct, anyone? All right. The calendar was not on this list, but I feel it should be, so we'll cover Roman calendars. So the early Roman calendar we think came from the Etruscans, but it's hard to know. It's a bit muddy at the beginning, but it essentially was an observational lunar calendar, which we will look at in a bit, and it becomes a lunisolar, which again we will look at in a bit. So this is the first calendar we got sort of reasonable details of. So you're familiar probably with Romulus and Remus. So this is Romulus, founder of Rome, gives us a calendar that has 10 months and a sort of unstructured amount of time at the end just called winter. So fine, I'm kind of vibe with that. I quite like that. Winter's just a bit right off for me. So his successor, Numa Pompilius, takes winter, splits it into January and February. Notice also we're beginning the year in March, which was typical back there. The problem with the Roman calendar was corruption, actually. They had a system for keeping it in line with the solar year. They had this month called intercalaris mensis, which was dropped in between the end of the year and the beginning of the year, but not always for astronomical reasons, sometimes for political reasons. So the Roman calendar is a little bit fuzzy, but Julius Caesar comes to power and says, this is a hot mess, we're going to fix it. So his calendar comes into play in 45 BC. It's obviously not aware it's BC at this point, but anyway. The Julian calendar has 365 days with leap years every 4 years, which may sound familiar. That's pretty close to what we've got right now. So, and it's correct within 11 minutes, which is kind of fine, but 15 centuries later, that 11 minutes has grown into 10 days. So the worry within the Catholic Church is that people might be celebrating Easter on the wrong day. That was generally what the reason for calendar reform was, to try and keep it in line with Easter. So a number of popes tried and died during the process, and the one who got it over the line was Pope Gregory XIII, and he issues the papal bull Inter Gravissimas, which is online. It's in Latin, but it's online if you want to have a go at it. It basically proposes changes to the leap year rules to improve the accuracy, which is the ones that we use these days. And then 10 days to be removed from the calendar to realign it back with the solar year, so we're celebrating Easter when we would expect to celebrate Easter. So, and it's pretty good. It's accurate within about 27 seconds, which is not bad, because it's fairly uncomplicated. It's pretty easy to follow. So adoption goes like this. So on the 4th of October 1582 in Julian, it's followed immediately by the 15th of October 1582 Gregorian. So you're jumping calendar systems. So that's the way to think of it in your head. You're not losing days or anything like that, but you're jumping systems. And it's adopted essentially in the Catholic countries. Britain, obviously at the time, the Protestant nation, doesn't want to do this. It takes 200 years to come along and then go, oh, right, maybe we should do what Europe's doing. Just saying. But the way they phrase it is they call it Old Style and New Style. They will not say Gregorian. This is online. If you go to .gov website, you can actually read the 1750 Act, and there's no mention of it at all. It's all New Style and Old Style. So the Old Style being the Julian, New Style is the Gregorian. So what happens in Britain? We get the 2nd of September 1752. Julian becomes 14th of September 1752. And also it realigns the years. There's two things going on in this act. At the beginning of the year, we were still celebrating the beginning of the year as on the 25th of March, but we realign it to the 1st of January. Scotland was actually already doing this since 1600, but because of the Act of Union, the wording of the act is kind of interesting. So anyway, that's what happens. I did promise you trying to unravel the tax year issue. So here's what I've managed to find. At 1752, the UK Treasury continued using the 4 quarter days that they were using previously. So that if you can imagine the days in the Julian calendar, all they've done is swap them to the Gregorian calendar, but they're using the same days. What they haven't done is move that beginning of the year. So if you think of the act here was doing 2 things, they're really only doing 1. So Lady Day was previously the beginning of the year, so that was 25th of March. That becomes the 5th of April, new style. So old style, new style. But 1800 comes along. That should be in the Julian calendar. That's a leap year, because every fourth year is a leap year. In the Gregorian rules, that's not a leap year. But the UK Treasury decided it was, and they get an extra day's revenue. Therefore, April 6th becomes the new tax year, and that's how the tax year got made. So that's how the sausage got made. It's really ugly. So I have to do Sweden. Sweden's really good. So everyone had to move from Julian to Gregorian at some point. So what happens in Sweden is they decide that it's very difficult for people to understand that we're taking 11 days or 10 days away from things. They're going to phase it in over time. So the plan is they'll go from the Julian to the Gregorian by omitting leap years over the course of about 40 years. And if you keep missing those out, then you'll catch up those missing 10 days. That's the plan. So 29th of February is skipped in 1700. And then they get involved in a 20-year war with Russia, and it's a bit of a mess, and they fall out of sync. So they're neither on the Julian at this point or the Gregorian. They're somewhere in between. King Charles the 12th decides, I've had enough, we're going back to the Julian. And the way they plan to do that is to add an extra day to February. That February was a leap year as well. So in Sweden in 1712, February the 29th was a valid day, as was February the 30th, and you have a year that is 367 days long. So great pub quiz question if you ever come across that one. They did eventually move to the Gregorian at some point in the future. So to wrap up Gregorian, it is the international modern civil calendar. It's adopted pretty largely around the world. There's a couple of places where it's not, but it's baked into the standards. So if you know your 8601 and your RFC 329, it's in there. So it's pretty much taken over. There's a couple of places that's not used, but even like China, this place, they still adopt the Gregorian calendar as the civil calendar, and then for things like religious events, then that calendar dictates all of those. So we'll kind of go into those calendars in a minute. I did say we'd cover French Republican. Just to give you a flavour of it, you should Google this. It's a really fun night. It comes out of the French Revolution, but you may or may not know the metric system also comes out of that period as well. So that's sort of in the air. So it seemed obvious that there should be a metric calendar. So what they proposed is the French Republican calendar, which is essentially secular metric, and it's intended as a replacement for the Gregorian. So it is used only by the French, obviously, for about 12 years, and then it's briefly used again for about 18 years during the Paris Commune. Just to give you a flavour of it, there's more than this. You should really Google it, because it's just great fun. The year comprises 12 months, okay? So far, so good. A month contains 3 weeks of 10 days, which are called decades, but that's another thing that'll catch you out. Each day comprises of 10 hours. Each hour comprises 100 decimal minutes, and each decimal minute comprises 100 decimal seconds. So the clock that you can see on the side here has both. You can see the 24-hour clock as you would expect it, plus it also has this sort of decimal time. So fascinating, absolute rabbit hole. And the calendar side of it is also something as well, but I'll let you kind of enjoy that on your own. Right, we'll look at lunar calendars now. So the lunar calendars, the interesting thing about lunar calendars is they're observational, as in someone has to look at them. So this is the Hijri calendar, I believe it's called. It's an observational lunar calendar, and it's really just used for Islamic religious events, Ramadan, Eid, this sort of thing. So it's used for determining when those are. So calendar day begins at sunset and ends at sunset, but actually lunar month begins with an observation of the crescent moon. So lunar months, as we've seen before, it's about 29 and a half days, kind of. So depending on observations, weather could actually change it between 29 or 30 days generally, is what you're looking at. And the year lasts 354 or 355 days. If you see that number cropping up, then you're looking at something lunar. Usually, if you're sort of a calendar wonk, you eventually sort of gravitate toward that number. So this is some of the observations taking place. So every Islamic state makes their own official observations. And obviously there's a bit of variability to do with the weather, and also obviously the observations are being made in different places as well. So Saudi Arabia has a calculated lunar calendar, so you can actually project in advance with some certainty as to when the religious events are going to occur, but the official dating is done through observation, so it can be a few days out. But and obviously Saudi Arabia is the most recent adopter of the Gregorian calendar as a civil calendar. So okay, we'll do lunar solar. I'm going to do this very quickly because I've had to cut some stuff just for time. But the Chinese calendar, so the Chinese are also on the Gregorian for the civil calendar, but all of the events, sort of festivals and auspicious days and that kind of thing, are taken from the Chinese traditional calendar. So we can date it to about the 14th century. The Yellow Emperor gives us the calendar, and it's, as I said, it's used for Chinese holidays and auspicious dates. 354 days, which may ring a bell, so you're thinking, okay, we're in a lunar calendar here, but it's lunar solar, so we're trying to bring the lunar calendar and the solar calendar in sync. And the way that's done is a process called intercalation. So you're looking for dropping in leap weeks or leap months or something to try and keep the lunar calendar in sync with the solar calendar as well, which is a very hard ask. So the Chinese system, they use a thing called the Ganzi system. It's sexagenary, so there's 60 in a cycle, and that's computed from 12 earthly branches, which you're probably familiar with from Chinese zodiac. That's the animals, as you would know them. And then 10 heavenly stems, which is a combination of yins and yang and 5 elements. You mix up all that soup and then you get the Chinese calendar. There's more to it than that, but Google it if you want to know some more. That gives you a flavour of it. I'm going to do day counts because these are super helpful if you want to do, if you can compute a day number, something really simple, you can jump between calendars, because you can get, if you can do it in 2 calendars, then you've got a way to bridge the 2, which is super handy if you're trying to do calendar conversion. So I'm going to tell you about the Julian period. We don't really use it, but you kind of need it to set up the next thing. So Julian period is invented or proposed by Joseph Scaliger in 1583. It's a mix of 3 things. It's got the 28 solar cycles, years essentially, lunar cycles, that's the Metonic cycle coming back, if you remember that from before, and 15 indiction cycles, which is part of the Roman tax year for reasons. So if you take all of those, set them back to 0, you get a point in the past that is prehistory. That's what he was kind of aiming at. So he can put a single number to any day in history, and you can tie it to a point in the Julian period. So what that looks like in reality, well, in practical terms, is you get a Julian day number, and that is a count of days since the beginning of the Julian period back in that prehistory. So the Julian day number is the integer number. A Julian date is the integer plus the fractional part of the day. So let's say, anything like 0.5 is the middle of the day. I'll cover the 0.5 now because it crops up in astronomy. So the Julian day numbering system comes from John Herschel, who is the son of William Herschel and the nephew of Caroline Herschel, if you know your Herschels in your astronomy. So that's the basis of it. But the thing with observational astronomy is if you're wanting to know exactly when noon is, you can measure that, because you can look up in the sky and you see when the sun is the highest point in the sky, I've got noon. Do 2 of those and then you've got a day, right? You've got 1 point and another point. And the benefit for astronomers as well is that if you're making observations through the evening, you just have to write the time down, because it's going to be the same Julian day all the way through, which is handy if you're lazy too. So. It's a big number. So at the beginning in the 1950s, we get a thing called the modified Julian day, which looks like this. So this is the Julian day. Take off 2.5 million, essentially, and a half. So we're now realigning it with the solar day. and it starts and ends at midnight. So this is super useful now. If we're trying to convert between calendar systems, we've now got something that is aligned with those systems. So the epoch is a lot sooner. It's 1858. And if you haven't guessed already, it's because computers in the 1950s didn't have a lot of memory. So we have a number that actually allows us to pinpoint a point in time all the way through to 31,000 AD, which I make to be Y31K compliant. Oh, very good, yeah. Right, so we're going to quickly do events and movable feasts. So if you look at today, all sorts of things in your calendar. I mean, I don't know if you subscribe to calendars. Sometimes I do just to sort of see what comes up. But if this is the 1st of June, then it is officially the first day of summer in the Northern Hemisphere in meteorological terms. If in astronomical terms, you have to wait another 20 odd days. But if it's first day of summer here, then it is the first day of winter in the Southern Hemisphere. Your Catholic saint of the day is Justin the Philosopher, looking foxy there. It's World Milk Day. Who knew? You know, it is also National Heimlich Maneuver Day. I don't know. Some of these events are hard to pin because we're used to seeing the calendar like this, with just events dropping in, and there's no. You can't see the patterns very well like this. I'm going to suggest looking at your calendar like this could be helpful, because you've got the Earth sweeping each month as it works its way around the sun, which is exactly what we're trying to measure, or what calendars are trying to do. But you can sort of plot on significant events on that sweep. So I'm not sure you can see that, it's red on black. But we've got the solstices and we have the equinoxes. So solstice in the Northern Hemisphere, this would be the shortest day at the top. You've got the longest day at the bottom, and then you've got a kind of equal days either side. You can do the quarter days as well. Well, actually, no, we give them names. So Christmas, you might be familiar with that one, yeah, Midsummer Day. You do the cross-quarter days, and before you know it, you've invented the pagan calendar. So there is ways of kind of seeing the patterns in there, and I think that's a really nice way of doing it. Right, I don't know how much time I've got left. Could I check? Oh, fantastic, 5 days. I'm going to speed run Pancake Day, because this is great. We're going to compute the day. We're going to just look at all the problems if you were to try and find Pancake Day in your calendar. If you had to do it from scratch, how you would do that. So the question, of course, is when is Pancake Day? So Pancake Day has several names, but it's Shrove Tuesday, which is great because it means we now know it's on a Tuesday. So we've tightened the search. So Shrove Tuesday is a movable feast. So a movable feast is anything essentially that is tied to Easter, because Easter moves around the calendar. It's a movable feast celebrated before Lent. So when is Lent? So Lent is the period before Easter. So we have Easter, we have Lent, and then we have pancakes. However, the start and end of Lent seems to vary. It depends which denomination you're in. I'm going to go with Anglican, as we're in the UK, but I can give you sort of alternative versions of this. Lent starts on Ash Wednesday for the Anglican Church, and it ends on Holy Saturday for the Anglican Church. The Catholics do it differently. There's other ways of coming at this, but essentially, for the rules that we're following today, that's the rules we're going to go with. So how long is it? Anyway, guess how long Lent is, because I had 40 days as well. That was what I had in my head. Sort of. Partly, well, I think this may be denominational, so I'm not going to say this is authoritative, but Sundays aren't counted, so it's actually closer to 46 days, which is, I don't know if that means you can sort of, I don't know. It's complicated. It's more complicated than it has to be. Ash Wednesday, the first day of Lent, is 46 days before Easter Sunday. So we have the trivial computation next of when is Easter. So this is worth a Google if you've got a week on your hands. There's a couple of ways of thinking about it. We have Easter in the Julian calendar, we have Easter in the Gregorian calendar. They're both, it's the same computation, just with different leap year rules. So that's good. Once you've got that, then you can kind of do your math slightly differently. But any way you come at this, you will end up here. This is the computist equation. And this was what was originally done by monks. The original computers were monks doing this calculation. So that's the smallest one I can get. And this is a whole talk in itself, so if you're interested, I'll maybe cook up something another time. But the computers equation is that. And it tells you that Easter Sunday is the first Sunday after the first full moon after the vernal equinox, which you knew, obviously. So Pancake Day is therefore 47 days before Easter Sunday, if Easter Sunday is the first Sunday after the first full moon after the vernal equinox. Okay, if you're interested in going down any of those rabbit holes, I recommend these books here. Calendrical Calculations is very good. It has source code, it's in Lisp, it's not open source, but it's the authoritative thing to read. And Astronomical Algorithms is really good if you're into like eclipses and stuff, it's really good for that. So, okay, that's me. Yeah.